So, I spent the last 2 days playing around with the Blueprint No Template plugin, and it's actually pretty interesting. I got a little bit ambitious idea and I actually managed to execute it somewhat. Yeah, I'm not sure if you're familiar with the actor model, but I'm basically using some concepts from that and I try to create like a system that could work, and it's actually not going too bad. So basically what's actor model is where you have actors, autonomous actors that can receive messages that they process information inside them and can talk to other actors, and that's kind of basically the basic setup. And from that you can basically create whatever you want. So that's kind of a thing that I was creating. So I tried to test it with the AI. So first, of course, I made the whole system and I tried to make it kind of work. And then I set it up with AI to kind of try to create simple AI and see if it actually works and if it's doable. So how it works is you have a message, you can send message, which is something like this. So you have an action in this. Ideally in here, blueprints are not that flexible, but what I wanted here is to have custom enums that you can change dynamically. So you can basically pick which type of enum you want in here or something like that. But since we don't have that, the second best thing there would probably be maybe strings, but they can be costly, and if there is a lot of messages, I didn't want to pass strings that then you switch on, and switch on strings is a bit more expensive, so I just decided to go with indexes. And basically what happens is index is one type of message, and then you deal with the messages inside of this actor. That's kind of the whole idea. And then the message can be anything from here except the sender. Sender is the actor that actually sent the message. And then you send the data in here. You can do custom data with a string if you have anything specific, but generally right now I think I only have been passing like object data, so I'm not even sure how I need to structure this. Maybe I'm doing something kind of weird, but so we're passing that, and basically what I'm doing is doing 4 things. Actually, let me first explain it conceptually, that would be easier. Yeah, so let's go higher level. So how this AI work that I created, it's actually simple. Let me show it first. This is just like a test to see if I could actually do something like this, but it's basically an AI that is randomly roaming, picking a new spot and then going around, and then when a player comes close, it's gonna go to the player and there is like an attack. Right now I'm just printing every 3 or 4 seconds it's gonna attack, and if I try to go away, he's gonna try to catch me and come close and attack me again. And if I go far enough away, I think I would have to go around. I'm not sure if I can even get away. Okay, he found me, never mind. Yeah, if I go far enough away, he's gonna stop going after me, and then he's gonna try to roam. Oh, I think I activated it. Oh, never mind, he found me again. But yeah, he starts roaming, and that's kind of about it. And on the higher level, how you would do this in behavior trees would be, you have like your main thing, then you have a sequence, and from the sequence you can do maybe like track player or something, then move to a random location or roaming. Or actually it's gonna be more complicated. You would have like roaming and the thing, then you have roaming here, the thing here, and then you have maybe attached service on the roaming, so you can continually track if the player is near you, basically. Maybe this is kind of the most basic thing. Of course you can do like, you might do like go to player, and then when you're close, attack the player. And this might be like a behavior tree, which is fine. There is some editing stuff that I'm gonna explain soon why I think this thing that I was testing was actually nicer than that, but I'm not sure about performance, but generally I think conceptually it's kind of nicer to work with. But how my system works is basically like this. You have this main actor, I just called it like AI master, and it's like an object, and we have some inputs, and it's kind of running its own internal state. And he can create other actors which are child actors of his. So it's almost like inheritance, but they're not actually child actors, I shouldn't call them that. They're just actors that this guy is the owner of. So that's my better explanation. So he's an owner, and how my system works is the owner in the beginning creates a child which is track. So this is like a track for player. So I think I set it to like 0.2. So every 0.2 seconds, we're just gonna check the distance to the player. Not this like, you wouldn't create this simple of AI, but just like as a test. And this is continuously running. So this would be like a service in behavior trees. And then depending on if we are seeing the player or not, we have two other, I don't know why I made them different sizes, but we have two other actors created. So if we see the player, we would create an attack, and then if we don't see the player, we would create a roll. And these actors are mutually exclusive, so you cannot have both of them at the same time. This is kind of how you manage states. And keep in mind, this is all not like pre-made structure. This is structure that is managed by the main actor. Let's call him M for master. So you'd have one of these two. Now, good thing about this system is that this, right now I made like Roman attack, but we could make it like more broad. So maybe this is, let's say, an alarmed state, and this is like a non-alarmed state or something like that. And then from here, what we could do is, let's say when you're alarmed and you are at low health, maybe you have another action which is like C, or not C, let's do H. H for hide, and then this action might be like find location, and then this might be like go to that location or whatever. And then we could have like maybe attack. Let's do R for ranged, and then maybe for ranged, maybe you first try to take cover, and then shoot from cover. And then maybe if you're not doing range, then you might have like melee. And then for melee, maybe you have like, jeez, that's disgusting. Okay, you might have like G, go to player, and then you might have attack or something. So this kind of how easily it is to expand, basically. So this task can then offload things to, I guess I could try, I don't like to call it children, because Unreal already has a concept of child parent for inheritance, and this is not inheritance. This is basically just like autonomous actors that kind of deal with their own state and can message to other actors, basically. And they can message each other, so this can request something from the owner, or the owner can send something to him. And good thing about this is that we don't have to have in one place like, let's say, 10 states for the character. So this character might be like, I don't know, idle, roaming, attacking, ranged, taking cover, I don't even know what else, melee. So this character could technically be in like 15 states. But you can imagine that managing 15 states just in like one thing, you would have to have like huge branches, a bunch of stuff. So managing, just having like one big thing and managing it there, it's kind of weird. And behavior trees have this weird thing. Services are kind of hard to use, so you have to attach them to the sequences, and then when the sequence goes to the tree, it goes to like the one branch, and it's only triggering that, and that one thing. That one thing needs to check for different things. How would I explain this? It would have to check for, like in here, since this is like a separate thing, this check for player, we don't have to like have check for player on each of these. So there's probably a better way to solve it in behavior trees, but you might have like a service or something, or you have to internally check for player. But in here, we just kind of check it on the side, and if at any point we don't want to check it, this main guy can get a message maybe and disable it. So we could do something like, let's say at some point someone in here wants to stop checking the player or something. Like we want to check for player to disable this actor. We could just pass the owner of everyone to the actor, and then tell the actor to send a message to the owner and say, okay, you can disable this this thing there. So it's kind of more flexible and nice. So yeah, that's kind of the general idea how it works. So let me just go over what I was testing. So this is the master, and this actor, I don't know if it's like actor design pattern or like actor model or whatever. It's not like actor model because it deals with the actual actor model is more for like servers to deal with processes, threads and stuff like that. And this is more just like uses some components of it. But basically what you have is you have your activate. This is kind of like begin play, activates once. You have spawn child. This is basically where you deal with rules on how you can spawn new children and what you want to do with them. Then you have your messages. So this is when somebody sends you a message. Here you deal with all the messages that you receive. You have error handling. This is basically if a child fails, how do you want to deal with that? So right now I have it on just resume your child. So the child says, I'm failing for some reason. You can just say, okay, just try again, I guess. But then if it's some critical error, we can say, okay, you can stop, or if it's network error, right now it says to stop, but it's not even for networking, so that network is not even used. And then you have terminated. This is basically when the termination happens of this actor. So what you want to do is terminate the children. So if we cut off the branch and that branch has children, we want to also terminate the children, basically. So I created a little macro for that, so we don't have to have like a big thing there. So if we are deleting this guy, we delete everything. And then we called on terminated, and this is good because then we can deal with that. So I have this delegate, and I'm setting it to an empty reference, and I'm gonna cover later what that means. Because there are some quirks with this. It doesn't work the best right now, but yeah, it doesn't deal best with terminating stuff. But yeah, we call on terminated event. This is pretty similar for each of them. I made it kind of custom here and not made it like deal with it in the actor core. Actor core is basically the original blueprint with my kind of template for how I want this to work. And I'm not dealing with the terminate there because I want the flexibility for each actor to kind of have its own. So maybe if there is some delay or something that needs to happen over time, it can quickly clean stuff up and then call on terminated and then gets destroyed, instead of forcing them to be instantly destroyed on each instance of the actor. And yeah, this is kind of the basic thing. We also have some interfaces. I try to make it simple to show you the 4 actors because it gets kind of complicated later. Or gets complicated and cluttered if there is like 8 or 9 things here. Okay, give me a second. So we have a few things here. So we have a state, and this is more of a state of the actor. So if I type state here, so this state is just a general state of this actor. It can be active, failed, and terminated. Failed basically means it's kind of on pause while waiting for the fail to be resolved. You can kind of choose if you want something to execute or not execute if it's in the failure state. So like here I have the check state. So maybe I don't want to spawn child if you're in the fail state, but maybe I do. So I could connect this and just make it doable there. So that's the general state. Every actor has a state. But then I have the state of this master actor. That is kind of a custom state that I just added it here. And you can see we have undefined roam and attack. And when we are undefined, we by default go to roam. And then we have the checks to see if we are seeing the player or not seeing the player. That's kind of the basic stuff. So basically what happens in this thing, okay, I also disable tick. But what happens in this thing is on begin play or on activate, we basically spawn a child. And when we spawn a child, we go here and then we have index 0. And ideally this would be anonymous, and then it will say spawn like check player distance actor or something like that. But we have to do with indexes for now. And then what we do here is basically spawn our check for player AI. We add it to the list of children of this object, and we also send a message which is just giving it a reference to the controller. And then what happens to this guy is when he spawned, he just checks the player pawn, we get the reference there. If for some reason the player is not found, we send it that it is an error, and it's set to non-critical right now, but maybe we need to set it on critical. But right now it's non-critical because we can just roam. Our character doesn't have to like freeze or something. Yeah, we can just continue roaming. Okay, so we get the player. This is how you get the messages. So we set the index 0, which means that we are gonna go to this branch and we are gonna go to cast a pawn, get the pawn reference, set the state to failed if we cast to the pawn, and this is a critical error, meaning that this guy is gonna be stopped. So this blueprint is gonna get stopped if we cannot find, if you don't get the pawn reference. That basically means we literally don't have the reference to this. And then the tick is basically, I set the tick to be like 0.2, I think. Yeah, 0.2. And when it ticks, we basically compare the distances between our AI and our player. And of course we have the terminating, but yeah. And we also added a custom, this is really good about this plugin, is that we created a custom check for player delegate. And if you go to the master, we are basically using that to send and update our player found. I could have also sent maybe something in here, but that might get complicated. But we could have also activated the function and maybe sent it and saved it in here. That might be a thing, but yeah, haven't tested that. But yeah, we basically update the player found and then we check the state. And when we check the state, we check basically where we are. So if we are undefined, we do this, but usually we're going to be somewhere here. So if you go to roam, if the player is found, we do something. If player is not found, that is fine, we just continue roaming. And if we go to the attack and player is not found, that means that the state needs to be changed. We go in here and we spawn a child, which is child NX1. So what does that mean? That means we go in here and we spawn the roam event, and keep in mind always want to terminate the children. So we find for the attack state, we find the attack and terminate it and spawn the roam, and for the roam the opposite. Yeah, and you can kind of I was thinking about different ways that you can modify states, and I think this is like a nice way where each actor handles few states and creates smaller actors if you need to like do some more specific stuff. But since right now our AI is really simple, we don't need to do any more specific stuff. This is all fine. If we had more states, like I showed with grafting, we would create substates and maybe we would rename this from, I don't know, roam to not alarmed or something. Or we could do like default, alarmed, attacking, or aggressive, or investigating. So you could have like few states. But I never want to have a situation where I have like 10, 15, 20 states. And I have one huge actor that has to manage like a bunch of states. Whew, okay. So we have this check actor. Pretty nice. We don't have anything crazy. We don't even have like a spawn child because we don't have anything to spawn. And a really good thing about this system is that we have these fail safes and everything's kind of enclosed and dealing with itself. So I didn't actually have, like, after I created these systems, I didn't actually have many bugs related to the actors, to their logic. It kind of worked most of the time. I didn't have much fixing to do. The most kind of issues I had was with this move to location and how I can manage that. I had to like save the task and on terminate stop the move task. Basically I have to stop this because this task, even if I destroy this actor, this task is still gonna be running. So I had to like do like most of my like problem solving was with this, not with actual setup of the stuff. The only thing is that it was a little bit slow in the beginning because I was learning myself the system, and I was also adding tweaking little stuff about how the base worked. But yeah, okay, so now we have roam. So when we go into roam, what happens? First, we don't have activate, so you can see that this system doesn't require you to like spawn everything. Like we don't have active, I think we have a tick even, yeah. Actually, we could do like activate, and we could do set tick, because I think tick enables by itself. And also you can see I'm always calling to parent. And the reason for that is that in the parent I added debug prints. So when I'm, let me clear this out. So when I'm playing the game and stuff is happening. Wait, why is he standing? Did I screw something with oh, maybe because I added this. No, convert. Oh my god, I think I found a bug. Okay. Let's add parent. Set tick disable. Okay, he's moving. Okay, I'm not sure what's the delay. Okay. So we can see stuff is happening, and if I pause, we can see that we have the log, and if I wanted to read stuff, you can see it says like which task was activated, attacking the player, roaming, terminate, and so it tells you that okay, so he was in the roaming, we had to terminate roaming, and then we went into attack and he attacked the player twice. And if you want to make it even easier, you can do something like this, and then you can see kind of the sequence of stuff that happened. Of course, I would maybe tweak this a little bit if I want to give more info for each print. So maybe which actor it is. Right now, it's if there is like 3 actors, it's not gonna tell you which actor, so you're gonna have a bunch of like prints that yeah, overlap and stuff like that. But for now, that's fine. Yeah, so we have move to location. And how this ROM works is basically he gets the message for the controller. So when he receives the controller, we start checking the roaming state. So if we don't have a controller, we don't really know how to check because we need the location of the pawn. And when you get that, we check the state similar way like we did first. We have this check state. So only when we are in the active state, we actually want to do this. So this kind of lets us freeze this actor. It would be nice if we could, if there was like some inherent support for this. But yeah, I'm not sure. It will have to be like the developer. This would have to probably add something. But yeah, the kind of like I don't even know how it would freeze because I'm using this to manually kind of quote unquote freeze stuff. But yeah, okay. So we go to switch and we start by default by search for location. That's kind of our default state. And we run EQS query. We create an event, bind to EQS query finished. And when we are finished with the query, we have the success failed, aborted, owner lost, whatever stuff. And we basically get the query results. We get the random location, we change the state to roaming, and then we check roaming state. And if there is some owner lost, missing parameters, whatever, we go and handle that error. If it's not critical, so the owner can deal with it however he wants. Then we have check roaming state. And here we have active. Oh yeah, so in here what I added is that we just go back if we failed or aborted. So if we didn't find any appropriate points, we just go back and try to search for points again. Now for this, it might have been better if we maybe added some delays or some waits or something, just so you don't like go through like bunch of points infinitely. Or we can also do like some error count, where if we fail like 5 times in a row, we just stop for like 10 seconds or something, or maybe even return like a failure to the owner. But for now, it's just set up like this, just so we have something. And then we're good to move to location when we're in the roaming state. That basically means that we move to location, we have accepted the radius, our roam location that we found, and we have this move to task. When we come to the point, we have a retriggerable delay. This just means that after 1 second we are gonna try again to search for location. After 2 seconds, if we succeeded, we're gonna still search for location. So they both do similar things, but yeah, I added different delays. And then you go back to check roaming state, so it kind of starts circling around. So this ROM actor does not actually manage if he's alive, his lifetime, stuff like that. That is actually left to the master. So the master decides when you want to terminate the ROM and when you want to terminate the attack, instead of this ROM actually trying to figure that out. And I could have, if I had even more states, instead of like checking each state, so maybe we have like 3, 4, 5 exclusive states. Right now, when we want to go to attack, we check if the ROM exists and destroy it, and vice versa. But if I had like more states than 2, I would probably do it a different way. Maybe having like a separate list of like active actors or like active states. So we have like one class, like we would have maybe like one variable that says we have a state right now and we can save the state there, or the actor there which is active right now, and then we can compare it with the actor that we want to be active, and if it's the same, then it means we are in the good state. Our states are synced with what we want to do. So right now I'm using it differently, but that's kind of what I would do. Okay, what else? Yeah, so that's a really nice thing where actors can just do their own thing, and then the master can manage this. Of course, if this guy was a master or had some children, then he would have to manage their states. So if we make like a bigger hierarchy, then there would be some different stuff, but yeah. Attack, so we have go to player, we have attack the player, we have the message. So when you receive the message, which is actor reference, we start checking the attack state. We first go to players, that's the default. And when we go to player, that basically means move to location, just get the player, and do some things. So if we failed, if we didn't manage to get to the player, we're just gonna wait 1 second and go again. And if we did, we go to the attack state. And attack state basically means we're gonna attack the player, print a little bit, wait 2 seconds, check if the player is still close to us. If he is, we attack again, and if he is not, we start going towards it. And that's about it. So this is kind of our system. I'm not sure how good this system would be if we like scaled it up, like actually try to create like a coherent AI. That's way more complicated, but I really liked it for this. And when I started going, when I really started warming up to the system, how it works, it started being way faster, where I just create a thing. I can go, okay, I need terminate, I need my terminate children, I need to call the event, okay, I'm having the message, okay, we need to check state, go in, break this, right? So it kind of goes fast. So it's not like I'm wasting, or it's not like it's really going slow. But yeah, I'm really interested how it's gonna work with more complicated thing. But yeah, I also wanted to test it with to create like a simple mechanic. So right now what I did is went a bit wider. So we have our master, so we have our check, our thing. But what I wanted to try with this system is also sequential stuff. So let's say we have a character, and I want this character to like grab an object, and when he's like holding the object, if he brings it close to another object, to maybe compare if they like fit, maybe like a puzzle or something. And if they fit, then maybe I want to create like a separate visual mesh that's gonna attach to the visually kind of show you where the pieces would be if they are connected, something like that. So how that would look like is maybe like this is like grab action, then we would have what would it be? So we grab it, then maybe this one would be like compare, then if we compare it could be and let's say we compare it and it's true, so this would be then show visually, whatever. So I wanted to go more like vertical instead of horizontal, so right now I went horizontal. So I wanted to do something like this and see how well this would work. But maybe actor is a bit like an overkill for this, but maybe not, I'm not sure. But yeah, really cool plugin. Like I think this actually feels like a feature that could be implemented like as a full feature for Unreal, and it would be real nice. And there is like one thing in Unreal that is kind of trying, I think, to do not a similar thing, but kind of to give you that customizability where you have like these like rules, states, and then you manage the states and stuff like that. Yeah, but the state tree is something that I think they want to do. I tried this state tree like more than 6 months ago, I think. And it had some potential, but I don't know, for me it was laggy, it was weird to use, some things didn't work, you couldn't like attach multiple parameters to different like branches and try to manage them. Like if you change somewhere, it won't change because you have it attached somewhere else or something. I don't even know how to explain it, but basically how it works is like you have your root, it goes from here, checks the branch, does some rules that the branch says, goes into sub-branch, triggers that. If it fails, it goes back, or you choose where it goes. So you have like kind of rules. If you want, like, you could go from this to the root. If you want, you could do like from here to just go to one sub-branch back. You could do stuff like this, which is honestly a little bit how this actor system that I created works. But I'm not sure how good it is in like 5.3, but when I checked it, it was 5.0 and maybe 5.1, I forgot. But yeah, I did not like the quirks with it. If it was like, when I played the game, if it was like visual showing me from through which branches it goes, and maybe it shows me like what decision it's making, so I kind of understand how the system works. Because with trial and error, it's so weird. Yeah, I don't even know how to explain it, I shouldn't even try. But yeah, that's kind of a thing. That's maybe doing similar thing. But this is a really nice feature. I'm not sure about performance. I don't think I had any crazy performance hitches with this system. Let's see, what's my FPS? I mean, this is like the worst way to check this, but 68, 70, but if I disable this, I mean, yeah, it's not gonna show anything crazy. But yeah, I don't know, I didn't see any performance issues with this one. Oh yeah, I also need to tell you about this, yeah. So why am I setting, when I want to terminate this master frame, I'm just setting it, this reference that I have in here to false. The reason is because this is a constructed object, it is not a spawned object, so you can't destroy it. And that is really bad, because that is really bad for us. I mean, it works fine as an object. The reason is that when I set a reference to false, that basically means that when automatic garbage collection or manual, when we call it, is called to check the objects that have no reference, it's gonna find this and remove it. So as long as this guy is referenced somewhere or saved, he's gonna be called. So we can basically do like clean the reference, and then he's gonna be destroyed when the next garbage collector goes. But then the issue, what can happen is, let's say we have a lifetime of our actor, and at this point we trigger, okay, we are destroying you. This actor is gonna go, and maybe garbage collection hits and cleans it, but it's still gonna go. So just because we remove the reference doesn't mean that the actor is stopping. So that's why we have the terminate, failed, and active branch. So we basically can tell the actor, okay, now if you're trying to go do something, you can do it. But ideally we would like destroy it or something, we do something with it. But since we can't, since it's just an object, we just, all that we can do is just clean the reference and wait for a garbage collection. Or what I was doing just for testing is just put the garbage collection right after we clean the reference. But this is a slow operation, so if you call it too much, it could bug down the game or make like hitches and stuff like that. So this would be like a real nice thing that the developer of this could implement, of this plugin, and yeah, help it get clean. I'm not sure what he could do, but yeah. Okay, the last thing, so I don't go too deep, is just to look at the actual base objects from which all of the other objects are derived from. So we have the state, we have the list of children, we have the owner, so we know who is the who created this actor, and then we have debug, and debug is just, you can put it in here true, false, and you basically call this print, and I have like custom prints for every event that I care about. And debug print is basically just a thing. And I created also, yeah, function library, macro library, stuff like that for this actor. But yeah, we just check if that debug is true. If it's true, we print. And yeah, that's about it. We also have the interface. This is important because this is how we send information from the child to the owner or vice versa. You have the send message, which every one of them needs to implement if they want to talk to each other. Terminate, on fail, stuff. Yeah, on fail I still haven't implemented in them, but basically since we have the handle error and we have error resolution basically means what are the rules so when we are resolving an error. So the child says, here is a critical error. Do we want on critical error to destroy and recreate the child? Maybe. Do we want to just resume it, just say forget about it? Maybe that. Maybe we want to just stop it, or maybe we want to like send it to the parent of this actor, or the owner of this actor. So you can kind of choose how to deal with it. And this is implemented in the owner, and then this is the child basically telling the owner what type of error they have. Yeah, and this is kind of things that you can implement. And the really good thing about this plugin is that you can basically set up the parent things even on the interface functions. That means that when we call the interface function is here like message, if we call the parent message, we get debug prints and stuff like that. I'm gonna be testing this system a bit more. I'm sure there will be some, it's not like performant or too optimized, but something like this I think would be real nice if it was optimized, because I really like the workflow. If you kind of create like little bubbles that are actors that can kind of, that are not coupled almost at all with each other and can kind of talk however they want. So maybe this guy is talking to this guy is talking here. You can kind of create rules how you want stuff to happen and who can talk to who and how they can talk to each other. And they're not like coupled together, and then they're all kind of strong alone, so they don't have to have this support that if one thing is like wrong, everything explodes. That's why I didn't have much trouble when I was creating each individual, while sometimes with behavior trees, stuff just doesn't work and I have no idea why, because just random thing. Like I had like with move to location task, I had so much issues with it where I was like checking stuff and then it was like failing, but we were in a sequence, which means that it's gonna go back through a branch and then sequence is gonna whatever. So it has like weird rules and stuff, and here the rules are like pretty simple and actors are kind of not lightweight in like performance way, but they're lightweight in how you deal with them. So if you destroy them, not destroy them, what's happening. It's like less like error proof, I don't know how to explain it. But yeah, really fun, really nice. This plugin is like, yeah, a really good plugin to be my first plugin to review. It's like, yeah, one of the best plugins that I can actually see myself using.